Welcome to This Explainer. Have you ever actually stopped to think about how scientists manage to organize literally everything in the universe? I mean, from the structural iron in a massive skyscraper to the invisible oxygen we breathe every second. It seems impossibly complex, right? Well, today, we're going to dive into the microscopic world and map out exactly how to categorize the fundamental building blocks of our reality.
Okay, let's quickly run through our agenda for today. First, a welcome to the matter map. Then, we'll break down pure substances, specifically elements and compounds. After that, we'll explore mixtures, both homogeneous and heterogeneous. I'll give you 4 scientific clues, we'll test your knowledge with a little practice, and finally, we'll talk about how to beware a very common visual trap. Let's get into it. Section 1. Welcome to the matter map. Before we can classify matter, we really need to understand what it fundamentally is. So, look around you right now. Just think about the everyday items sitting on your desk or in your kitchen or out your window.
I'm going to present 4 everyday items to you, and I want you to quickly guess which of these actually count as matter. Here they are: salt water, trail mix, an iron nail, and a simple glass of water. So which is it? Well, the reality is all 4 of them are matter. They all have mass, and they all take up physical space. But take a really close look at that trail mix. Unlike the glass of water, you can clearly see the different parts: the nuts, the chocolate, the raisins. That visual distinction, it's going to be a massive clue for us in just a minute.
And this brings us to our overarching classification map. This is basically how scientists sort everything. We divide all matter into 2 main branches based on what the atomic particles are doing. On one side, we have pure substances, which includes elements and compounds. On the flip side, we have mixtures, which branch into homogeneous and heterogeneous. Literally every physical thing you interact with falls somewhere onto this map.
Section 2. Pure substances, elements, and compounds. Let's zoom in on that first major branch.
The most fundamental pure substance out there is an element. Basically, if you were to look at an element at the atomic scale, you would see that every single particle is identical. It contains only one kind of particle. Every single atom is exactly the same, making it perfectly uniform all the way down to its core.
To ground this in reality, just think about elements in the wild. The copper in your home's plumbing, a solid gold ring, the oxygen we're breathing right now, or the iron in a heavy nail. These are just one type of atom, pure and simple.
Now, the second type of pure substance is the compound. Here, you actually have different types of atoms. But, and this is absolutely crucial, it still behaves as a pure substance because those different atoms are physically connected and chemically joined together. Because of that chemical bond, the resulting molecule acts as one single uniform building block.
The ultimate everyday example of this is water. It's made of hydrogen and oxygen, 2 entirely different elements, right? But because they are chemically bonded into H2O molecules, they form a pure substance. Every single particle in a glass of pure water is that exact same bonded molecule.
So just to quickly summarize that left side of our map, elements have only one type of atom. Compounds have different atoms that are chemically joined, but they are both classified as pure substances because, in either case, every single particle in the sample is exactly the same kind of particle. You're dealing with one consistent building block for the whole shebang.
Section 3. Mixtures, homogeneous, and heterogeneous. All right, let's jump over to the right side of our map and see what happens when different substances share the same space but without chemically bonding.
First up is the homogeneous mixture. These contain multiple substances that physically share space, meaning they are spread out completely evenly, but they are absolutely not chemically joined. Because of this even distribution, the entire sample looks completely uniform. Think of a brightly colored sports drink, or lemonade, or salt water. There's definitely more than one ingredient in there, but visually it just appears as one smooth liquid. Contrast that with a heterogeneous mixture. Remember that trail mix from our first exercise? In this case, the separate substances are not evenly mixed. A slice of pizza, a fresh salad, that handful of trail mix. If you can visually identify the different sections and ingredients with your naked eye, you are looking at a heterogeneous mixture.
Section 4. The 4 scientific clues. I want to give you a foolproof little cheat sheet to help you classify matter efficiently.
I highly recommend locking these 4 clues into your brain. Ready? One type of atom means element. Different atoms joined together means compound. Mixed evenly and looks the same means homogeneous. Mixed but with clearly visible parts means heterogeneous. Let's do that one more time. One is element, joined as compound, same as homogeneous,
Different is heterogeneous.
Section 5. Practice. Test your knowledge. Okay, time to put your new detective skills to the test.
Consider this real-world scenario. A student mixes water, sugar, and lemon juice in a pitcher. After a good stir, the drink looks completely uniform throughout. Based on those 4 clues we just talked about, how would you classify this type of matter? Take a second.
If you guessed homogeneous mixture, you hit the nail right on the head. Our claim is that lemonade is a homogeneous mixture, and the evidence is solid. There are multiple substances present, but they are evenly distributed, so the entire mixture looks exactly the same throughout. You are thinking exactly like a scientist.
Section 6. Beware the visual trap. Now, I have to warn you about the ultimate boss of matter classification, the illusion of uniformity.
The trap is this. Just because something looks completely uniform to your eye does not automatically guarantee it's a compound. Pure water, which is a compound, and salt water, which is a homogeneous mixture, look completely identical to the naked eye. The defining difference is entirely microscopic. You always have to ask, are the atoms actually chemically joined? If yes, it's a compound. If they are just sharing space without bonding, it's a homogeneous mixture. And honestly, this reveals a totally fascinating reality. Our eyes really only tell us part of the story. If visual uniformity isn't enough to distinguish a compound from a mixture, how will you investigate the hidden, microscopic truth of the materials we interact with every single day? That requirement to look past the surface and evaluate the real evidence, that is the very essence of science. Thank you so much for joining me for this explainer, and keep questioning the matter around you.